bland Altman now. Any other person before we move to the bland Altman? Any issue which you have faced? So what should I do? So like Dr. Shamshad is asking a question from all of you and even me too, that since bland Altman is again a topic which will take at least 1.5 hours, including the hands-on and all. So it's 4 because we thought it will finish by 4:30, but I think it took long for all of us to come into the same level. So what do you guys suggest? Should we continue now or should we keep it on some other day? This bland Altman. We can sit till okay, again there will be mix. Okay, so what I can do, continue. So what I can do, we can continue till 5, na? So I will continue till 5 because people now they come here to just lock the door. So probably I'll continue till 5. And then if something left, then we can continue that on some other day. So I'll start with bland Altman. Or if possible. So now bland Altman is another, you can say it's a spectrum of analysis for seeing the basically the absolute agreement for this continuous type of data. And here it not only tells you the agreement, rather it tells you the exact value also. What are the individual points? And we will see in what cases it is suitable. So this is like, again, I am doing the same activity which I did for ICC. So they are the 6 patients and I'm measuring the blood pressure device of by the 2 instrument, the manual versus a digital. And since I know that I want to replace the manual device because digital is easy for me to in practice. I just want to see what all error I can tolerate by seeing these things. So what I did, I had just done the difference between these two. So if you see the difference, manual versus digital, so this is the difference, like -2 +2 plus -5 +1 -1 and -2. So if I see the mean difference, so this mean difference of the values, that is known as the bias. Remember, we have talked about the systematic bias. If this is constantly in the session 1 of ICC, we have seen that the 2 instruments were, one instrument was constantly reading +5. That is known as the systematic bias, where the one instrument is constantly reading 5 millimeter higher. But in this case, you can see that this digital, sometimes it is measuring less, sometimes it is measuring more. And this is a difference, mean difference, and this mean difference is known as the bias. And how we will calculate? We will add it and we'll take out a mean of this. And if that mean is 1.17, what will I read? I will read that this digital device reads generally 1.17 millimeter lower than the this is minus. That means yes, this manual reads higher. So digital device, no, we have done this manual minus digital. And if it is minus, that means digital device, it is reading 1 millimeter or 1.17 millimeter higher than the manual device. And if you calculate the standard deviation, there will be a standard deviation of this difference also. So standard deviation of this difference is, if it is 2.44, then we set a limit of agreement. So we introduce a term which is known as the limits of agreement. Means how much variation you can tolerate. If the mean is showing this much, and there is a formula for it. So if you go by this, we have shared one article also. So bland Altman proposed this analysis of bland Altman curve, and they have said that instead of correlation, we should use this bland Altman analysis, which works on the difference, mean difference, and then it tells you about the limits of agreement. So the limits of agreement, the formula is you mean plus minus 1.96 into this standard deviation. So this limits of agreement comes like -6 to 3.7. So how we will read that? So we will read that 95% of the values, the difference between the devices lies between -6 to +4. This is my limit of agreement. That means in 90, if 100 cases, if this digital this sphygmomanometer reads out of 100, 95% of cases, the difference may be, it may read 6 millimeter less or 4 millimeter more than the manual. So now, is this acceptable limit for me or not? That I have to see. And we'll see how to decide for that. So what basically Bland Altman does? So we know correlation and we know ICC. So in ICC, what is happening? Basically in ICC, you just see the how ICC works. You have seen the variance between subject and within subject. And ICC works on the principle of ANOVA. ANOVA means it takes the variance, what is the true variance as compared to the error due to the observer or due to the random error. But Bland Altman, but this ICC doesn't tell you exact value up till what it is acceptable. That means if there is a systematic error of let's say 5, or if there is an average error of let's say 1.17, is this error acceptable to me or not as a clinician? Or will I allow this digital sphygmomanometer to screen my hypertensive patients or not? If as a clinician, I have to do this decision, then I cannot go only by ICC. I have to do the Bland Altman because Bland Altman tells you what limit of this difference I can tolerate being a clinician. So that's why it defines you, which is known as the limits of agreement, and it looks for bias also. So what is bias? I'm introducing a term which is known as the bias. Here I'm not saying whether it is a systematic bias or any other bias, because systematic bias means constant +5, +5, +5. So here bias is random because sometimes it is plus, sometimes it is minus. So it bases on the basis of that, it defines a limits of agreement. That means range within which most differences will lie. That means how we define it, like I have seen, we have seen in the previous one, mean plus minus 1.96 multiplied by standard deviation of the differences. This is how we define the limits of agreement. That means this is the range where the 95% of the values will fall. So now, why Bland Altman is different as compared to the ICC? So you know that correlation. If you just recall the correlation, why I will always be talking the correlation to compare the ICC and Bland Altman, because I said in the beginning that this ICC was invented and Bland Altman was invented as a superior method of the correlation as compared to the correlation. So that's why this is, sorry. So this correlation, if you see this ICC and correlation that works on variability. Variability means if I have got a patient where all the blood pressures are within a very narrow range, the correlation will be very less. It will be very less, although there will be a good agreement. So Bland Altman doesn't take into account of the variability. So that's why it adds to your analysis, that it works irrespective of the variability of the person or the subject which are there in your population, in your subject study subjects. So it is a method. What is a Bland Altman method or plot? It is a method that shows us like how far those values are. The difference between the two instrument or the two rater, how far that difference is, and whether that difference is acceptable to us or not. By this, we come to know this. So generally, you see that we make combination. We do ICC and Bland Altman both. One part takes care of the variability and the other parts take care of the individual values and how far those values and whether those differences acceptable to us or not. So along with the consistency, it focuses on agreement also. Because
but in ICC was not focusing on agreement too. Ma'am, like when we were doing the JAMOVI, then we were selecting agreement or consistency.
So that depends on your research question. In ICC, you can select agreement. Why not?
Okay, but in ICC doesn't take consistency and agreement along with each other. We can say that.
Okay. You want to say like both together.
Yeah, ICC doesn't take both together, right, ma'am?
Yes.
Okay.
ICC, either you can do it for agreement or you can do it for consistency. But in agreement, you see, like you have to check like absolute agreement and range of values. That exact value ICC doesn't give you. Like by the value of ICC, what you tells? You only tell that there is an agreement between the two observer or between the two instrument, and it is able to pick, let's say, 90% of the true variation, and it is as close as 90% of the true value. But what that value is and what that range will be, that it doesn't specify. So for that, you need the bland Altman plot.
Because it
Okay.
gives LOA, limit of agreement.
Yeah. We
That's
will
why.
see limit of agreement, like what values, what is the deviation, what is the bias. It is one step ahead. You can start with ICC and then you plot this bland Altman also, just to check the individual value and individual data point, and you set your limit of agreement. We will discuss, there are 13 parameter to discuss this bland Altman plot. So once we deal with all those points one by one, it will be clear to you how and why you should do the bland Altman. Now, why not only ICC? So coming to this bland Altman, generally, so let's see first the different, understand the idea of correlation and agreement together. So in this case, this is one data set here. You can say that this is a data set of 5 patients, and this is the BMI and the systolic blood pressure. So we have learned this earlier also, that this correlation is between the two different variable. So what do you think, whether they are correlated with each other or not, just by seeing the data? What is your idea? Please write in the chat box. Yes, because as this blood BMI is increasing, it is 20, 26, 30. If you rank it, again it comes as rank. And this is again like 110, 122, 130, 138. So they are correlated with each other. Now we are measuring the same blood pressure, but with two devices. So this is device 1 and this is device 2. So now, what is your idea? So should they just move or should they give the same reading? So they should give the same reading, 120, 122, 135, 138. So it is not differing much, only a value of 2 to 3 differences there. And again, if you see this data, what is your opinion again? There are two devices. Again, they are moving together. This is increasing and the device, this is also increasing. But again, the difference is very high here, 20, again a systematic difference of 20 millimeter. So, but again, which Ashish was asking, but can I use this SBP device 2 instead of device 1? If device 1, I think if it is the manual one, and I consider that this is a better validity, means accuracy is better in device 1, and I want to replace device 2 with device 1. So, or can I use these devices interchangeably? No. Why? Because there is a difference of 20 millimeter. So I cannot use in a clinical setting, because 20 millimeter is too huge a difference for a patient if that error is there. So like this is the key reason why the correlation and agreement is not same, because the two device, it can correlate perfectly, but still they may have a poor agreement, and that leads to error or the clinical error. For example, two thermometer may correlate perfectly, because again I said correlation work on rank. It perfectly works on rank. Whereas in case of agreement, I want exact value. So high correlation doesn't mean high agreement. So agreement is a safe substitution. So now if you go to the this Norman, they always say about this bland Altman that it is a asset and it is a liability, both, in case of a bland Altman. So what is this asset and liability in context of Bland-Altman plot? Because we say that Bland-Altman doesn't talk about the variance and variability. So it is independent from the true variability of the observation. So that's why, because I mean, you see that if there is a variability, then only ICC works, because ICC works on the principle of variability, and even the correlation works on the principle of variability. But for Bland-Altman, this does not matter what is the variability. So difference, because it works on difference between the two methods. So that's why it is independent of the true variability of the population. So that's why it is called an asset, because it works on the principle of agreement without being distorted by how diverse my patient group is. For example, if I study the blood pressure measurement with two devices, where most of the blood pressure is concentrated around 120 millimeter of mercury, then my correlation might look very poor. But Bland-Altman will still show me where is the actual bias, how much is the actual bias, and what are the limits of agreement between these devices. But there is a liability also, because if you don't report the actual variation, let's say if the device A and device B differs by a value of 5 millimeter, which we were talking since the beginning of the session about a systematic bias. So will that plus minus 5 is acceptable to me? That depends on the variability between the people. So if I have got range from 90 to 200, high variability, then this plus minus 5 is trivial. But if all patients are around 120, then it could be clinically important to us. So Dr. SS is asking if data distribution is not normal. No, we have got assumption, then we cannot use Bland-Altman. Then you difference. Data means you are talking about, we are only, this Bland-Altman works on the difference between the two uh, values. So we plot the difference. We will see in the assumption, Dr. SS, we plot the histogram and QQ plot of the difference, and then we see if it is normal, then only we can go with the Bland-Altman. Otherwise, you have to do the log transformation of those differences, and then you can perform. So now this is a typical Bland-Altman plot in JAMOVI. I will explain these each and every line which you can see here in the Bland-Altman plot. So if you see, this is your y-axis and this is your x-axis. So x-axis plots the mean, and this mean is the individual mean. Mean of observer 1 and observer 2, or mean of device 1 and device 2 data. And here on the y-axis, it's the difference, means difference between the two devices. So remember, we will talk now about the two values, mean value and the difference. Difference is x1 minus x2 means two devices, and mean means for each person x1 plus x2 by 2. So this is your x and y axis. Now, if you see this black line, so this black line, it is around 0. If you see this value, this is 0. 0 means it is no bias line. That means if the difference is 0, that is your ideal situation. If the two instruments or two people are giving exactly the same reading, then only this difference will be 0. Am I making sense to all of you or not? When will this difference, if you are measuring this difference 1 and 2, when will this difference will be 0? If they are measuring giving the exactly same value, then it will be 0. So that's why this is known as the no bias line, this 0, 1, 0. Then comes your next, which is the mean bias line. That means it is the mean bias. The bias which you have seen here, 1.17. That means if you see the value, it is approximately 5. It lies between 0 to 10. So if I need to see the value, what will I say? This, my mean bias is 5 millimeter. Okay. That means device 2 is constantly reading 5 millimeter high means no, not constantly, because these are the points. We have to see the individual points. This line is across the mean bias line. Then what are the shaded area? Can you see this shaded purple area? This shaded purple area is the confidence interval of the mean bias line. Then your next is your lower limit of agreement, and this shaded area, this orange one, this is your like dash line which you can see here, this line and this line. So these are the two lines are the confidence interval of the lower limits of agreement. And then you see the upper line. This is the upper limits of agreement, line of upper limit of agreement. This one, this dash line. And this shaded area, the whole is your confidence interval of the upper limits of agreement. And then these are your individual data point. These are your individual data point. And then you see the spread. If you see the spread, can you appreciate any pattern in this spread? These are all random, means at the lower value and at the higher value. Both value, they are distributed randomly. You cannot make out a pattern. Yes, there are few outliers. That means this value, this lies outside this. Again, this lies outside this. But again, there are very few, only two values. Otherwise, most of the values are inside this. So this is a typical bland Altman plot in the JAMOVI. You know about, again I will revise, this x and y axis. So y axis plots the difference between the two measurement. The x axis plots the mean of the two measurement. The line which passes from 0, that is the no bias line. The line which passes from the mean of the difference in your data set, that is your mean bias line, along with the confidence interval, which is the shaded area. Then there is a lower limit of agreement and its confidence interval. Then upper limit of agreement and confidence interval. Am I making sense to all of you up till this point? Okay. Then I'll go ahead. Now there are two concepts. There is something known as the proportional bias and there is something known as the systematic bias. So you all know the systematic bias now. If there is a constant amount one instrument is reading, either high or low, it is known as the systematic bias. And then there is something known as the proportional bias. What do I mean by proportional bias? As you move towards the higher value, the change increases. And we'll see that in the graph. How in the graph you can see whether it is a systematic bias or whether it is a proportional bias. So, see this graph. This is a bland Altman plot. And can you see some pattern? What is your comment? You see here focus on this area and then focus on this area. So what is your comment? If I take this value as 140, this is the 140, average of the two method as the 140. Okay. So what is the difference you can see? Yes.
For more than 140, we can see increase in the difference, but it
Yes.
is still consistent.
Yes. So very rightly said. If you see the plot less than at a lower value, that means less than 140, it is, you can see there is a random distribution. But after 140, you can see all the points, they are moving towards the difference is becoming high. Here it is concentrated up till, let's say you can say 20. But here the difference has gone up to even 25 and few values are even higher than that. So this is known as the proportional bias. That means as the average value increases at the higher value of blood pressure, the difference between the two divides. that is not same. That means it gives you more error. This is known as the proportional bias. Again, we'll see that. Now comment on this.
Ma'am, can you please repeat the interpretation of proportional bias, ma'am?
Proportional bias, the term proportional bias means there are two values here. Like let's say blood pressure. There's a lower value of blood pressure, what we called it as your study subjects has got high range of blood pressure. There's a person who is having a blood pressure of like let's say 60 also, and there's a person who is having blood pressure of 200 and more than 200 also. So if a person is having a blood pressure less than 140, the error or the difference of the bias is less. It is concentrated, let's say 20, and it may read, if you see the line of 0, this is line of 0.
Ma'am, you mean difference in measurement is less, right, ma'am?
Yes, difference in
Okay.
measurement, because we will talk about the difference in devices now.
Okay.
So difference in measurement, you can see it is less.
And
Here,
this difference in measurement, we are calling it as bias.
yes, of course. This is bias. If it is fixed, like at every time it is 5 plus 5, we call it as a systematic bias. If it is random, then we call it as a proportional bias. Proportional bias means at higher value, it shows you more error. Means that difference from the manual, it shows the large number of error, more amount. That is the proportional
As
bias.
the average value increases, there is higher error.
Yeah. Means, no, at higher average value, the error increases.
At higher average value, the error increases.
Yeah, now the difference is more, no? You can see here. Again, this curve you can see. Here, what will you see? That it is random.
Consistent.
Yeah, it is
Random.
consistent. True. So this should be the ideal blunt Altman plot. So proportional bias is like the magnitude of difference. It depends. It is rather than depending on the size. It depends on the percentage. Like the error grows or shrink as the value increase. So in this case, like device B, if it reads 10% higher than the device A, that means at higher, as the difference gets larger, this value increases. So you will see a pattern. So if you see a pattern means upward or downward slope, we will see in JAMOVI, we draw a regression line and we see the slope of that. That shows whether there is a proportional bias or there is a systematic bias. Because systematic bias is easy to tackle. Like we always say, remember that the digital always reads 10 millimeter higher than the manual. So if someone tells you that whatever value comes, you just add plus 10 and that read it. So if it is a systematic, that means if it is constant across all values, that is still okay. But if it is a proportional bias, then you need to give the range. Like in our case also, I was telling you the example of lactate, one along with the ABG, with the lower value of pH, it was showing a good agreement. But at a higher value, the error was high. So that's why we are using that with caution in our field setting. So systematic bias is what? A consistent shift between the two methods or raters. So one method always gives values that are higher or lower by about the same amount. That we know the systematic bias. Like device B reads the plus 5 units more than the device A, regardless of the value change. But in case, so the points, if you see the Bland-Altman plot, the points are centered above or below the zero line. And in this case, you will see that the mean difference is clearly shifted. Clearly shifted means it will be not be zero. If you see this is your mean difference line. So shifted means it will be away from your no bias line. No bias line. And this is your systematic bias. So now, what is the, if you just, if I want to summarize this systematic bias, so systematic bias stays constant. And the bias does not change with size. Size means at higher value of blood pressure or at higher pH value also, the value of the difference will be same. So it is a horizontal shift. But in case of a proportional bias, the bias does not stays constant and the bias change with size. That means at higher value of blood pressure, the error will be more. So the slope, there will be a slope. If you see this, this is a horizontal shift. If you see this is a horizontal shift. But this is not something like this. The line is not like this. So that's why it is not a proportional bias. But in case of a proportional bias, it will give you a slope or it will give you a funnel pattern. So that's how in a bland Altman plot, by seeing the values of those individual data point and seeing the spread of that, you can see whether it is a systematic bias or it is a proportional bias. Am I making sense to all of you up till this point? Then I'll move further.
Yes, ma'am.
Okay, thank you. Again, if you see this plot, this is so showing a systematic bias. Why showing a systematic bias? Because there is a horizontal shift, but you cannot see any pattern. All are randomly distributed. If you see this also, this is again, yeah, they are evenly. So without systematic bias and without proportional bias, wrongly written here, without a proportional bias. So now if you need to make a 2 by 2 table of whether the proportional bias absent or systematic bias absent. So ideally in your case, like if you want a device to be interchangeably, generally you want your proportional bias also to be absent and systematic bias also to be absent. So this is your ideal case where there is no bias and the devices are interchangeable. But even if there is a systematic bias, but there is no proportional bias, this is also acceptable because you may allow for correction. Like I was saying, you may write that this lactate meter reads 0.1 pH higher than the ABG, but it is a fixed one. So this still is acceptable for me. But if there is a proportional bias, then also I need to see what is the value, up till what value it is acceptable. So I may write that this is acceptable only if the blood pressure is up till 140. If it goes beyond that, you cannot accept this instrument. So this is again, it needs adjustment. And this is not acceptable at all when both the biases are present, whether it is when it is proportional biases also and when it is systematic bias also, you cannot accept it. So am I making sense to all of you regarding the presence or absence of systematic bias and proportional bias? Dr. S.S. Rai is writing yes. Anyone else? Yes or no? Can you write something? Or should I repeat this? Understood. Thank you. Now I'll go to the, let's say, like I was talking about the assumptions. So this bland Altman, we have got assumptions also. So it actually, what this bland Altman tests, it tests whether there is a systematic bias or not. Systematic bias means average shift. And then what is the magnitude of that bias? So that mean bias along with its confidence interval, we have to report. And we have to see whether the difference, whether it is normally distributed or not. I think Dr. S.S. Rai or somebody was talking about this normal distribution or not. So there are key reporting. This I was telling you. This is very important. And we have shared that article with you where it suggests you how to report a bland Altman analysis. And they have, I think they have reviewed, let's say 200 article or something. Na? 600. Something they have reported. We have shared, I guess, that article with you where they have reviewed 300 or 400 articles reporting the bland Altman. They found out many key components which were missing from those reporting. So that's why we are taking reference from that article, and I think we have shared that article to you people in the this thing group. So you can go through that also, and it suggests a 13 item to be reported and assumptions to be checked in case of a bland Altman analysis. So since they are 13 in number, I'll go slow and I'll explain each and every point one by one. So the first one is you should have a pre-established acceptable limits of agreement. That means, like I was talking about the lactate meter and the ABG, or the two blood pressure devices. So as a clinician, I should be writing this, that how much acceptable limit of agreement I will tolerate. That means, will it be plus minus 5 or will it be plus minus 7? So let's say for pH, I have to set that I will only tolerate a acceptable limit of agreement of plus minus 2.2. Okay, that should be told from the beginning, and that should be fixed. The second is we have to describe our data structure, like number of raters or the block design. What is the raters means? Are we taking 2 raters or 3 raters? Then third one, we have to estimate the repeatability of the measure. That means in this, I have explained this in the subsequent slide one by one. So first is we have to set the limits. So we have to define the difference between the two methods. It would be considered acceptable before doing the analysis. This I have explained. In case of describe, I have to mention how many subjects I have taken, how many raters or devices, or if I am doing some repeat measurement. Like for blood pressure, if I am taking only one measurement or two measurement, that I have to write. And we have to check whether the same method is repeated, and if it is repeated, how it is consistent. Like that's why you see that many times we report ICC also in along with bland Altman. So repeatability means if my study design involves that I am using two, like repeat means now and after 5 minutes, then I need to report ICC also, what is the agreement between the two values. And when I have got either the multiple, and in this case, whenever I am measuring this replicates means when I am measuring one subject more than one per method, like multiple rater or repeat runs, then I need to estimate the within subject variance and between subject variance, which we have talked in ICC. But the bland Altman doesn't have a built-in mechanism for this partition. So that's why it is always desirable whenever you have got a repeat measurement. That means one value measured more than one per method or by multiple rater, then you need to report the ANOVA. ANOVA, not ICC, because ICC works on ANOVA, so you should report the ICC. So here you can see that there is a connection between ICC and bland Altman, because ICC uses the ANOVA framework to split this variability. And you know that we define ICC as a ratio between the between subject variance and the between subject variance plus error. So once we report this alongside of the bland Altman, then bland Altman is very good at giving you the limits of agreement and the mean bias, but it doesn't give you the variance component. So together you can tell both about the magnitude of differences and the sources of differences. That means the variance, whether it is able to detect the true variability or there is more of error. So for example, like I am just taken this example, let's say 10 patients, each measured twice by 2 raters. So there are 20 observations because there are, we have done the 2 measurement. So per method. So bland Altman, if it is says like there is plus minus 2 millimeter mercury of bias and limits of agreement is like minus 5 to plus 10. And if ICC is like between patient variance is 80%, then I may, if I'm reporting both ICC and bland Altman, I may write that device B reads average 2 millimeter higher than the device A, with 95% times the difference is between the minus 5 and plus 9. And the 80% of the variability is due to the true difference between the patient, and 20% is due to the within subject variance or the rater error. So that's how we have to report ICC also if there are more than one rater or if we are measuring it more than one time. So now you have to plot the data also. So you should use the scatter diagram or histogram, because this bland Altman, one of the key assumption is like it should be normally distributed, this difference. So we plot histogram and QQ plot for this difference. And this option is there in JAMOVI. So if any trend is there, like bias increasing with value, that will be shown in the this normality plot. And we have to report this distributional assumptions also, because I said that generally it works, it assumes that differences are normally distributed. Because if there is a differences are skewed, then again the limits of agreement, it will be misleading. And if the assumptions is not satisfied, then you may need to transform the data also if it is needed. And again, then what you do, you report the mean bias. Mean bias means the average difference between the two methods that you see, it comes as output also. And you need to show whether one tends to read higher or lower. That will be shown by the sign, whether it is plus or minus. And then you can see whether it is the mean difference. What is the bias line? Remember that initial plot, that this bias line you need to report. So if I can again put that diagram, this one. But the good, this thing is JAMOVI, that it usually involves all the component. So that's why you only need to see JAMOVI option, and then you can rest assured that. So I am again pasting that slide here. So like I said, so you will report all this. The mean bias line along with confidence interval, the upper limits of agreement along with its confidence interval, the lower limits of agreement along with its confidence interval. Generally, in the article, they have said that people, they don't report the confidence interval of the limits of agreement, but that is also needed. So precision, what is precision? Precision is the standard deviation of the difference or the 95% interval around the bias. This they are calling as a precision. This purple one. Okay. And then limits of agreement, we have to plot the limits of agreement, which is 1.96 standard deviation in our plot. And we have to show the confidence interval of the limits of agreement also. It's not only the limits of agreement, but rather the confidence interval also. And if you see this JAMOVI, this gives you the limits, this gives you the confidence interval, like this green shaded area and this peach or orange shaded area. This tells you about the confidence interval of the limits of agreement that you have to report. And then so we have seen like pre-established acceptable limit of agreement. We have to describe our data structure. If there are replicates or repeatability, we have to show the ICC also. We have to check the normality and trends of the difference using the QQ plot and histogram. If it is not normal, we may need to transform the data. We need to report the mean difference along with its confidence interval. We need to report the bland Altman limits of agreement along with its confidence interval, which is the 9th point. Then the 10th point is indicate if measurement range is wide. Here we need to, this is a limitation in JAMOVI, that this doesn't, the test which is available for this, it is not there in JAMOVI. We'll see. And the 11th point is you have to state software in which you have done this bland Altman. And this report distributional assumption is again the same normality concept. So this measurement wide enough means like whatever subject you have taken, they are showing a wide range of value. Let's say for blood pressure, they are showing blood pressure from 60 to 200. They are having all the values. They are not only having the healthy or the diseased people. For example, like if you are comparing the two blood pressure device, and if you only test them with the blood pressure range of 100 and to 130, the bland Altman will show that it is an excellent plot. But when you apply the same values to a patient who is hypertensive, then it would not capture that. So this is a liability. Remember, in the beginning, we were discussing the asset and liability. So asset is like, it is good that it doesn't work on variability, but many times for generalizability, you need to show the variability also. So for that, you need to report the ICC. And again, there is a test which is known as the, I'm only tell you this from the academic point of view, because in JAMOVI, this option is not there. This Price-Fisher procedure, which is a statistical test which uses, but this option is not there either in JAMOVI or JASP. But if you want to remember, you can remember it. Again, you can perform some descriptive data analysis to see how much is the data. Like if you give them the range, the lowest and highest value, then that maybe gives some amount of the variability of your data set. But this option is not there in JAMOVI. And but again, with ICC, you can report the within subject and between subject variance, which we have seen earlier also. So what this bland Altman analysis reports, we have seen the graph, and now we know what are the components. So now I'll go to the breakout room and I'll see. So not I will go means you have to go. I will show the this demonstration. So this is bland Altman, and this is the ESR. This is the article which we have shared, and this article measures the comparison of, like they did the ESR measurement, comparison of erythrocyte sedimentation rate measurement by the automated SEDI system and conventional Westergren method using a bland Altman statistical method. So you can see the Westergren they have used as a standard one. And this point of care device, this automated, they want to test. So you can see they have again divided this, this is the normal, they have shown as a correlation. And then this is the bland Altman plot. So if you don't see, I mean, I have not done the analysis, but by seeing the bland Altman plot, what you can see, can you see a systematic bias or a proportional bias in this case? What is the random? Pardon?
Proportional.
I
Yes.
think
It's a proportional, because you can see there is a, if you draw a line, it is something like that. This is not random.
no.
It is not random. At higher value, again, if you see somewhere at here, up till this point, up till 25, 20 or something like that, then the difference was more, the change in the value. And if you see, they have also plotted. Okay, not here, maybe some other. There was one more article, na? Where the BMI, they have calculated it at, okay, that was the mix, okay. So this is the one which I am going to show you. So this is the exercise. So exercise is again the same. The lab is considering switching from the manual Westergren method to an automated device to improve efficiency and reduce the biohazard risk. But before this change can be approved, it is important to determine whether the two methods provide comparable. So now I am working on the principle of interchangeable. So whether I can replace this or not. So each blood sample by measured once by the Westergren and then 3 times by the SEDI system, and then it was averaged. So I took the average value. So if you come here, I have to use the bland Altman plot to provide the sufficient agreement for the clinical use and to see whether it has got any systematic or proportional bias and what are the limits of agreement. So I'll go to the data set. So for that, you need to download a module, which is the bland R. You just in the plus sign, you type blind Altman. I'll show you. Go here, type, go to JAMOVI library and type bland Altman. You see bland Altman method comparison. Since this is installed in my computer, so that's why it is writing installed. So I will open this. Now you can see it has got three options. Bland Altman analysis, and this is assumptions. QQ plot difference of QQ plot and histogram of difference and density curve. So before I move, I need to check these assumptions. And then in the raw output, I need to check about these raw statistics also. So I will go to this bland Altman. First, I'll check with this difference of QQ plot. So I will move this ESR Westergrain here and average here in this case. So these are the the values. Here I have calculated this difference and mean value, but you don't need to do this. You ignore these two. You ignore these two. It's not needed. I was just checking. So if you see the difference of QQ plot, you can see it is across this line. So I can say that it is approximately normally distributed. Again, I can go back and see the other one, which is the difference of histogram and density. So I'll check that. I'll move this Westergrain and the ESR CD average because I'm taking the average value for my analysis. So this is again showing a normal distribution, kind of a normal distribution, this histogram and density plot. So that means I can say that my data is not, no, it is normally distributed and I don't need to transform that. So this option is there in bland Altman itself. Now comes your bland Altman analysis. So I'll click that bland Altman analysis and I'll move this ESR Westergrain here and this average here. And I'll wait. It will show you the plot. So this is the bland Altman plot and this is your bias and limits of agreement. So bias is 5.12. That means average, the device 2 is reading 5.12 millimeter. Okay, it is a Westergrain. That means this is reading, SEDI is reading 5 values higher than the Westergrain. And
No, but this is in positive, no? But
okay, let me see.
this is in positive 5.12.
Yeah.
So it means Westergreen will show a higher value, right, ma'am?
Oh, yes, you are right. Westergrain minus this thing. So the SEDI is 5 millimeter less reading. You are right. It is showing 5 millimeter less, which you can see here. Just a sec. This difference, actually, it doesn't mention, but again, difference is, I think, from first to second, because you can check also in the data set that this is your average, this is your Westergrain. If it is reading 97, then your yes, mean value was there, no? This difference was, it is 98. If you see the mean, difference is -1. Minus, yeah, but this 97 and this, it is your 98. So you can see the individual values also, but I think ESR, you are right, it is reading high. If it is giving plus, yes, it does the 1 minus 2. So it is reading low. Okay. So there is a systematic bias of, not systematic, there is a mean bias line and the values show that this is 5 value, 5 units. Whatever will be the unit of a measurement of ESR, this will be 5 lower than the Westergrain with the 95% of the values between 4 and 6. This is your interpretation of first. Now coming on the limits of agreement. The limits of agreement, the lower limit is -7.42 and the this is your confidence interval and the upper limit of agreement is 17 with the confidence interval of 15 to 19. This is your interpretation. And again, there are two more options which I have not ticked. One is the, so what will be your interpretation? So your interpretation is like, if you have set, let's say I have set my, because in the reporting of the bland Altman, the first step was I have to set a limit of agreement a priori. So if I have set a limits of agreement a priori as 10, that I will tolerate only up till 10 plus minus 10, then this limits of agreement is more than my, the lower limit is okay because plus minus 10 and its confidence interval is also within my limit. But this upper limit of agreement goes higher, and even the upper confidence interval is 19, whereas my limit I have set as 10. So I will say that this device is not acceptable because this limit is going up above than my limit. I can only tolerate. So I will say that for lower values, means for reading, the lower limits is okay, but my upper limit is not acceptable. And if you click this proportional bias line also, so you can see here that it is showing you a slope. So this blue line, although this blue line, if you see, this blue line is the line of regression. So this line of regression is tilted. That means there is some slope. That means at the higher value of, although from the graph it is not very obvious. From the graph you will see, you will say that it is like randomly distributed. But if you plot this regression line, proportional bias line, if there is an angle and if it is not parallel to this, then you can say that proportional bias is present. And this high overlapping point means at one point, the darker point which you are seeing, there are many, like 2, 3 people who are having at the same coordinates of this mean and differences. That's why these darker points are here. So that means N. N2 means here there are 2 people are here at this point. So this is your overall like interpretation of this, and then comes your raw output. So if you click the raw output also statistics, again if you put this method 1 and average, it will give you the statistics. That means this t value is 9.4. Basically in statistics, it uses a one sample t-test. One sample t-test means at this difference, it calculates the difference as against this. If you hypothesize a value of 0, is this value of the 5, the difference of 5 which you have seen here, this one, is this difference is statistically significant or not? For that, it runs the one sample t-test, which is the bland Altman statistics, and it will tell you the t-value, which is 9.8, and the p-value. So p-value here is the e to the power minus 16. That means it is highly significant. So the true bias is not equal to 0. So this, the bland Altman statistics, which tells you that this difference of 5 millimeter, is this difference statistically significant or not from 0. You can run one sample t-test also to check that. For that, I have used this because for that you need to calculate this difference and mean value. So this difference I have calculated using a system of option of compute, and this mean also have used a system of compute. So if you like run a one sample t-test, I'll go to the analysis and use the one sample t-test. Here also, if you move this difference value here and you use this test value as 0, you can see it gives you the, if you see the descriptives, you can write here mean difference and you can write the descriptives and the difference of this thing. So you can see here also it is giving you the mean difference of 5.2 with the t statistics of 9.8. This thing with a p-value of this thing with a degree of freedom of 149. It is same. This t, degree of freedom, and p-value. So am I making sense to all of you? Have you understood this? Bland Altman? So while reporting, if you see, I don't know, can you show me the chat? Anyone written anything or do you, okay, so Prashant has written the last message. Anyone? Do you want me to repeat? But it is, I
Madam,
mean,
Madam, this proportional bias line, it is existent, but the angle is not much. So should we report or should we take into account? Is there any
actually,
significance?
actually, for this, ideally they say, actually, I was trying not to input, but since you have asked, actually, what you should do, you should you should run a linear regression because sometimes this line is confusing. So, what you should do, you go on this regression and you do a linear regression. You take the difference as a dependent value and mean as a covariate. And you see the coefficient that is slope and its confidence interval. So I'll go to this model coefficient and I will see this confidence interval and 95% confidence interval of the estimate. So you see that if the 95% confidence interval, if it has 0, that means its proportional bias is not significant. See, this is your estimate.
Yes.
The beta, I mean that slope, this is your slope, beta coefficient.
Right.
We call it as a slope, okay?
-2 plus. Okay, it is
Yeah, it
involving
is
0.
involving 0. So that's why you can see that angle was very less.
Yes.
So
Yes.
generally, I was not telling you, but since it is good to check because they say in the article that it is not sufficient to see only the proportional line. You should check with the linear regression, the slope and its confidence interval. So if the confidence interval of the slope includes 0, that means this proportional bias is due to the random error, and that is not significant. Did all of you get this, what I'm talking now?
Yes, ma'am.
Okay. So this was all about the Bland-Altman. So any questions? Hmm? So breakout room तो अब रखना नहीं है because it's already 5:20. So we are not having a breakout room, and also we have seen we don't have those many mentors also. So you can practice. The video will be available to you people. The data set will be available. In case of any problem, you may post your questions also. You can go through the analysis, try doing it, run regression, run independent sample t-test. I will just show how you can create, but we have shared the data set where you have these difference and mean. I don't know. Let me check. How you can create this? Go to the data, click this, click the option of compute. When you click the option of compute, here you will get an option of average. So mean. So click this mean, and in this mean, I have to take the mean of Westergren method and put a comma, and then take the average of this and then press enter. So you will get this mean value here. Give a name to it like mean underscore 1. So this is your mean value which I have created here. And for difference also, how you will do? Go here and select the variable. So difference, I am doing the difference between Westergren minus this average, and then enter. So this I have created. That's why Ashish was telling if it is positive, that means by the second this SEDI is reading 5 millimeter less. So you are right. because the variable which I have created, this is Westergrain minus this thing. And then you can run a linear regression, keeping this as a dependent variable, the difference, and the mean as an independent predictor. That it shows that with higher value of mean, this is not changing. It is not changing if it is not significant. So Altman is writing no. What do I mean by no? Not understood. Altman? All good. Okay. Thank you. So I think so you are
Ma'am,
not
one request, ma'am, can you also share the PPT with us?
Yes, we always share
Okay, ma'am.
recording and PPT. Somebody
Yes,
has
sir.
written.
तक नहीं हो पाएगा आज।
Maybe it will take. I mean, we will not be able to.
कल शाम में करेंगे, आज
So
नहीं हो पाएगा।
actually tomorrow also there is a medical education workshop going on. So we have our sessions there. So probably we'll share the recording by tomorrow night
Sure, ma'am.
to all of you. And PPT, everything. Somebody has written, I'm not able to locate what? Can you see the message? So Sarosh has written, I'm not able to locate the data.
ड्राइव सब शेयर्ड है, ग्रुप में भी है, ग्रुप
Can you open the, it will be with the OMV file.
एक्सेल शीट भी है और
We have given you the Excel sheet you can import also in your own.
सब कुछ एक्सरसाइज फाइल भी है उसी में।
Everything is there in the Google. We have shared everything with the Google Drive. So you will find everything, all these data set.
Madam, where is the Google Drive's link shared, madam?
In that link, if you will click on that link, you will get it.
Yeah, I didn't get in my email, so that's why I put a request.
ईमेल भी किया था, ईमेल हो जाएगा।
Okay, then we will.
ईमेल में भी ड्राइव लिंक शेयर किया है।
Can it be shared here also, if possible, in the chat?
अभी कर देते हैं।
Okay, we are sharing.
डिस्क्रिप्शन में, चैट के डिस्क्रिप्शन में, ग्रुप के डिस्क्रिप्शन में।
Okay, Dr. Shamshad is saying that in group description it is there.
Always there.
I'll show. This is the workshop. If you click on, can you see my screen?
Yes, madam. I think I'm not added to the group. I think I didn't join the group. Yeah.
Okay. So we are adding you, and this group link also you can see group description. Can you see a drive link here also here?
नहीं तो ग्रुप में नहीं देख पाएंगे।
Yes, madam.
अच्छा फिर इनको शेयर
मेल चेक करने के लिए मेल नहीं करता।
ये इसको अभी कॉपी करके ग्रुप में डाल दूँ?
ग्रुप में है नहीं ना।
No here right now chat.
हाँ चैट, हाँ कॉपी कर दे चैट में। नहीं ग्रुप, हाँ चाहो तो कॉपी करके डाल दीजिए।
Okay, I am.
लेकिन वो मुश्किल होगा ना, उनको कॉपी कर दीजिए, हाँ चैट में डाल दीजिए।
ओपन लिंक आ रहा है।
मेल किया हुआ है।
Can you share your email right now in the group?
Sure, madam.
In here chat, not group, because you are not added, so that's
Sure,
why.
madam. Yes, ma'am.
मेल किया है, मेल किया है।
फिर भी एक बार भेज देते हैं if he's saying that he has not got.
हाँ सरोज अहमद, drsarosh@gmail.com.
Dr. Shamshad is saying that grsarosh@gmail.com. We have sent, probably it may be in your spam or some other folder, but we are sharing it again.
Okay, madam.
Okay.
Okay, madam. Thank you. I'll wait.
We are sharing it, and if you don't get it, you can mail, na?
मेल कर रहा हूँ।
Okay, you just confirm. Dr. Shamshad is.
Yeah, I checked my mail. It's not there. So, yeah. I think it's the reminder mail. Got it, madam. I got it. It is a spam actually.
Oh, that's why many times your messages, if it is full, na, it goes into spam. That's okay. So you may, like, we are done with the blind Altman, and thanks for your patient listening that you could stay here for long. And again, in case of any query, you can write to us. The videos and all the content will be available to you people probably by tomorrow night. Okay. So thank you to all of you. And we are ending the meeting from our end.
Thank you, ma'am.
Thank you.